and Ma'am Lian Bag.
And of course, our advisor for this subject, medical nutrition therapy and nutritional biochemistry, Sir Wilmar June Elopre. Virtual hand, please. Grabe, ang supportive talaga, partner.
Yes, partner. Oy!
So guys, kumusta ang tanan? Kumusta, partner?
So, okay ra, lumalaban jud. Kulba man din na partner,
Kaayo,
no?
partner, ay. Pero despite sa kakulba, partner, we feel so great. I feel so great and overwhelmed, partner, to see kanang familiar faces and also new names, no? New faces, partner. Kay medyo dugay-dugay na kita nga wala nagkakita and tananta, I know, tananta ga-hope nga unta na makamit na punta pohon.
Yes, partner. So it really feels so good to start this semester with a webinar, partner. So, excited mo ba to, partner?
Of course, excited ta. Dili lang kita ha, dili lang kita. Tanan ta, excited.
Yes, mo jud unta na ko yung pangutana, partner, no?
Yes, I
So,
know.
kung excited po na ato ang 101 participants for this webinar, please flood the chat box with your designated emojis. Katong naka-assign sa nga mga emojis from alpha amylase, beta glucans, and the rest. So, sige na go, flood na ta sa ato ang mga chat box. So, ayun, I see
Wow,
from
representative
beta-glucans.
beta glucans.
Okay.
And also, guys, you can also type in your shout outs. Pwede na mo siya i-read. If gusto gid mo nga, maingon inyong pangalan.
Kasi dili mo katulog niya. Uy, naman ang mga carrots from beta carotene.
Wow, naara.
Ayun, tora, partner. So, hello. How about from alpha amylase? Mga ate. Ayun, gabaha ang ato ang mga third year and also second year.
Oh, good PM.
So, ayun, grabe. Legit good partner nga gibuntag nila nga atong carrots.
Yes, partner. So, moving on, before we proceed to our top proper partner, of course, na-jud tayo pampa-excite sa ilaha, partner. Oy, aside sa ato ang ma-learn karon. So,
Yes,
right
partner.
now, we will have a game, partner, pang Alive Alerts Awake sa ilaha. Partner, please introduce ang atong game sa ilaha, please.
So, our first pakulo, partner, kanang dili kaya niyo siya ginagamit sa mga online webinars. Basig kita pa'y first nakagamit ani partner. Cheers! So, our first game for today is our 4 picks 1 word, where we will be flashing photos, 4 photos, and you will be guessing what it portrays. So, dili namin maghatag og mga sample. So, diretso na ta, partner.
Yes.
And reminding everyone nga naani siya Gcash. So,
wow. Pwede mo join?
Uy.
Pwede kita mo join?
Pwede lang, partner. Okay, let's start with our first one.
Okay, guys. Guess. Unsa ni?
Unsa na?
Pagkaon?
Hindi.
Oh,
So,
fruits.
may nag-answer of fruits. So, dili siya fruits, guys.
Guys, reminder ha, dili kami ang judge, dili kami magbuot kung kinsay first naka-type in, atay judger garing dapita.
Dili siya nutritionist, dietitian.
Wala po kung kita.
Uy! Ako'y nakita, partner.
Oh my God, happy.
Ako'y nakita, partner.
Okay, go. Uy, ang Gcash kay kuan daw ni House and Lot.
Okay, we have our first winner.
Wow, we have our winner na day, partner.
Yes, partner. So the correct answer is nutrition. So Ivy Giselle Noto got first.
From beta glucans, of course.
Yes.
Okay, sige, congratulations, Ivy. Okay, the next one, unsa ni partner? Unhealthy
partner.
Unsa ni?
Partner.
Di ko guess.
Oh my Coke.
Unsa ni? Alam niya sa Coke, oy.
Uy.
Wow,
partner.
Daghanang naka-answer sa, oy, wow. Nanatay winner, partner.
Okay. Uy.
Wow, our winner is Megan Josephine.
So, ay pagpabor-pabor. Diet. Morning na ay Coke na partner. Kay diet Coke.
Diet na yung Coke. Ana din na siya, partner. Oy. Okay, so next, please.
Ay, mga keyboard warriors na niya. Go. Uy.
Ala,
Sa
Sa ni elephant ni? Lagi maklaro.
Partner, dili na elephant.
Ay, sorry. Sige, go guys. Yes. Important gid siya guys, promise.
Dili ko magsabak o kinsay naghimo ani. Dili siya alcohol. Oy, Harvey, dili mo paklaro, Harvey.
Ay, dili ha, dili. Harvey. Okay, wala pa naka-answer. No, dili siya glucose.
Dili po siya
Try
ribose.
guessing
Pero
word by word,
hapit
guys.
ang
By
ribose
picture.
nila.
Try guessing by picture. No,
Dili siya pentose
by
fat.
Wow!
Oy, hapit! Hapit!
Ay, nako'y nakita, I think.
Napod kayo nakita, partner.
Wow! Congratulations! Mr. Harvey, Kurt Harvey Jimeno. Grabe, ning pag-spitag lukans. Uy, mura mag-warrior, magaling mga kamot.
Yes, partner. Pas-pas kay kamot, partner. Oy,
Rhino, din na siya.
disclaimer,
May
ha?
Raibo. din na siya,
Yes.
partner.
Disclaimer ha,
Tapos,
wala naman sila pangtuluan sa answer.
Grabe. Grabe ka-update. Kawiti, oy. Okay,
First.
next, tabi. Uy, unsa ni? Naday ron ang kaning COVID, partner?
Ang good partner. Murag,
Yes,
try
guys.
kumahingig ka may partner.
Murag sayon-sayon ra gid ni siya, promise.
Ay, depende pa partner. Murag ako lang kabalon sa
Oh my God, happy!
Kulang.
Ay, happy.
Kulang.
Kulang. Sama kulang. Kanang COVID
Nashay.
no. Wow
Uy.
na. Wow eh.
Ayun.
Grabe.
So, congratulations.
Dati.
Our winner, Mr. Patrick John Gonzalez. Last na dayo ni partner, no?
Yes,
Ay,
partner. Unsa ka ni?
So, as you can see no, na siya hashtag. Baka ni partner. So, mani nga mga pa-question.
Unsa kaya ni? One word ra ba ni siya, partner?
One word.
One word?
dapat,
Ay,
partner.
one word lagi di ay. Unsa kaya ni ba? Grabe ako nagbasa sila sa katong kuan nila partner ato ang PubMat sa Facebook page.
Yes.
Promise maka-answer sila ana.
Added to. Uy!
Hi! Oh my gosh.
Dapat
Please.
one word na siya.
I-plus star imong answer.
I-plus star sa I-plus star.
Natoy hapit kagaina, nakoy nakita.
Oo,
Ah,
naka-partner
kaway, sir,
pero
kinsa
dapat
ka?
one word na siya.
Yes. You see, oh my gosh. Dili, oh my gosh. Move on
Guys,
na ng
kung
answer,
guys, na siya yung hashtag, guys.
Hashtag. Ano yung keyword? Hashtag.
Na siya yung hashtag.
Wow, naana tayo
Oy,
naka-answer.
ayun.
Ay, mo yung keyword. Hashtag na rin ang keyword, partner.
Yes! Tora, nakita na nako. Congratulations to Courtney Diago. So, congratulations to all our winners for our first Pakolo partner, no? Grabe jud ka mga active.
Yes, grabe, partner. Bro, naka-standby lahang Gcash silang tapad. Anak, gila na
Yes,
siya.
We will contact you later, guys, ha? If makuha na ninyo yung Gcash. So,
Okay,
moving
partner.
on, partner.
Yes. Before we formally start our program, may we call in our department's chairperson, the very compassionate, active, and beautiful Ma'am Alin May and Marapaw. Virtual applause, please.
Hello, a pleasant afternoon, everyone. Can you hear me?
Yes, ma'am. Good afternoon.
So it is my pleasure to welcome all of you to this Nutritional Genomics, the path to personalized nutrition webinar. So which is truly a brilliant topic, no, to discuss among aspiring professionals in the field of nutrition. So which comprises all of us present here today. So nutrition, as we all know it, is the study of nutrients in food, how the body uses them, and the relationship between diet, health, and disease. So, thus, for every food we ingest, there is a need for us to know also its absorption, assimilation, biosynthesis, catabolism, and excretion. So, review na ni guys. Also, we have the term genomics on the other hand, which is an interdisciplinary field of biology focusing on the structure, function, evolution, mapping, and editing of genomes. So, as we recall our topics in genetics, we have the term genome, which is an organism's complete set of DNA, including all of its genes as well as its hierarchical three-dimensional structural configuration. So, in combination, we have the term nutritional genomics, also known as nutrigenomics, no? Which has been broadly defined as the relationship between nutrients, diet, and gene expression. So the launch of the Human Genome Project in the 1990s and the subsequent mapping of human DNA sequencing ushered in the era of big science. So jump-starting the field of nutrigenomics that we know today. So having a good understanding of nutrigenomics will bridge the challenge now, which is how to define the optimal intake of individual nutrients for the maintenance of human cells in a genomically stable way. Hence, the conduct of this webinar. No? I hope with this activity, it will empower each of you, our dear participants, to dive into the complex biology of human beings, making a mechanistic understanding of exactly how dietary bioactives react in our bodies, which is actually difficult to elicit. No, to the organizers of this webinar, the Pan-Alpha Pi chapter, in collaboration with the batch beta-glucans of the Department of Nutrition and Dietetics, I thank you and I sincerely appreciate your efforts for this webinar. To our dear speakers, Mr. Jacos S. Nasis and Mr. Wilmar Jun Elopre, thank you very much for accommodating our request to speak and share insights about this very important topic. So to all our participants, thank you very much for sharing your time today and for supporting this activity. I am confident that all of us will gain valuable insights and additional knowledge from this webinar. Once again, I welcome you all and keep safe, everyone. Thank you very much.
Thank you very much, Ma'am Aline, for that very warm welcome, no? So, partner, grabe ang pag-welcome pa lang ni Ma'am Aline. Dagan akong learn.
Yes, of course, partner. The way mo storya si Ma'am Allen, grabe gid siya ka-warm.
Yes. Online platform pa lang ni guys. Unsa na lang kag face-to-face. So, praying for face-to-face?
Kuhon.
Yes naman. So, partner, ay sunod na to.
Unsa kaya? Nag-game taga-inaw say sunod.
Basin. Game na po?
Ay, dili.
Naka-prepare di ay. Naka-prepare. So, our next pakulo, dili mo siya pakulo, partner. So, we will be having an intermission number to be given by someone who everyone knows. Of course,
Wow,
siya
grabe.
kanina. So, put your hands together for an intermission number to be given by my partner, Miss Maria Angela Oclary. Virtual applause, please.
I guess
I was still a child, didn't get the chance to feel the world around, had no time to choose what I choose to do. So chance to feel the world around me. Had no time to choose what I chose to do. So go easy on me. I had good intentions and the high results, but I know right now if nothing could achieve it, show. Go easy on me, baby. I was still a child. I didn't get the chance to feel the world around me. I had no time to choose what I chose to do. So easy on me.
Wow, grabe akong partner. Oy, amin ako si Adele to ay.
Easy na
Sir,
to.
kilala na to si Adele?
Di ampo, pero kailan po sa iya.
Sabi kong nabisi si Adele karon, pero karam di silang balay.
Na okay ra gyud.
Grabe,
how-
partner
Grabe
ba?
partner, despite of the katong difficulty nga atong na face gaina, mas maayo gid ay partner no nga face to face na gyud ta pohon magkanda og
Yes.
webinar.
Dapat magkanta na jud ka face-to-face partner ha. So grabe. Thank you for sharing your God-given talent with us this afternoon. So,
Ay, maliit na bagay.
uy,
Wait, member kong G4 sa una. Ow, sorry.
partner. More
Sayo
sayo to
na.
G-Force.
Sorry. You stop na kring kay mga dagko na tong atay ring dapita.
So,
Okay. Moving
we'll
on,
be
partner.
flashing our
Yeah, we'll be
attendance
flashing.
code first. Yes. So, here is our first attendance code. So, please take note.
everyone.
Screenshot na ta and all mga people of ND.
Alright, I guess partner, kung na sila naka-screenshot, dali na ba nilang kamot? Di ba gaina sa answer, dali na ka sila nakatubag?
Yes, partner. Grabe, paspas kayo.
Okay, so moving on partner, aren't we all curious about the title of our webinar today? What is it partner?
Bita, na-mention pa to ni Ma'am Aline ganina. So, the title of our webinar is the Nutritional Genomics, Path to Personalized Nutrition. So, mo ni ang ato ang panaghisgutan karon partner. So, without further ado, feeling na ko excited ang tanan para makatuon karon nga hapon. Partner, please do the honor to introduce our speaker for this webinar.
Thank you. So to tell us more about that, may I introduce to you our speaker for this webinar. Our speaker for today earned his degree in Bachelor of Science in Nutrition and Dietetics at Central Mindanao University in the year 2015 as cum laude. He ranked top 3 during the Nutritionist Dietitian Licensure examination in the same year. He garnered his certificate in biochemistry at the University of the Philippines, Manila in the year 2021 and is currently a candidate for a Master of Science in Food Science at Central Mindanao University. He was a part-time nutritionist dietitian at Agnisio Ventures Incorporated in the year 2015 to 2016, a health enumerator at Asia Pacific Management and Research Group in 2016, and a part-time nutrition counselor at Professional Marketing Insights Incorporated in the year 2018. He is a registered nutritionist dietitian at Nutriverse Diet and Nutrition Care Services and is currently affiliated as a college research coordinator and instructor 1 at Central Mindanao University. Please help me welcome our speaker for today, Mr. Wilmar June Owe-Lopre. Virtual applause, please.
Hello everyone, good afternoon. Can you hear me?
Yes, sir. Good afternoon.
Can you see my face?
Yes, sir.
Okay ra no, makitaan ra. Oh, I'm not sure manggod. And I'm currently experiencing like difficulty in connecting the internet, although dili kaayo. So just advise me if gawala-awala or choppy akong tingog. Okay. So good afternoon again, everyone. I'm very happy that finally we are now conducting this kind of webinar with this kind of topic because it's really high time, as what Ma'am Allen said ganina, no? And I can see that most of the BSND students are here. So I'm happy for that. And I can also see people who are not affiliated with CMU in any way. So welcome po to our webinar. And for the information of everybody, this was initiated because in my nutritional biochemistry courses for the 3 batches, wala kaayo na ako na incorporate ang topic nga nutritional genomics, no? So I am seizing this opportunity to um, have a topic like this in a webinar form. And we are very lucky that someone from the Food Nutrition and Research Institute will talk about the application of this young science, no? And hopefully that will shed light to everyone, because even the professionals, those who are already registered nutritionists, dietitians, medyo kulang pa yun, no, in this field. Okay, many of us still need some degree of enlightenment, no, regarding this topic. So I'm glad, I'm also proud that the beta glucans batch, as well as the Philippine Association of Nutrition Alpha Pi chapter, which is the Central Mindanao University chapter, is able to conduct this kind of webinar. Okay, so yeah, so you know na the theme of this webinar, and my part is to talk about the more on the introductory part of nutritional genomics as a science, as an authentic science. And tomorrow's part, which will involve, no, Sir Jacques from the FNRI as the resource speaker. He will be talking about more on the application side, uh, or on how to practically apply the science of nutritional genomics to cater individuals through the principle of personalized nutrition. Okay, so murag ang ako lang a part, no, is more on para mas masabtan ninyo ang mga terminologies nga istoryahon, no, ni Sir Jacques tomorrow. So let me share my screen. Okay, to the organizers, no, I cannot start screen share while the other participants sharing. So can you enable that button for me, please? Okay, na. Sige. So, okay, so kanisha guys, are you able to see the presentation already?
Yes,
The
sir.
title slide. Okay. So the basics in nutritional genomics. Okay. So the outline of my presentation is as shown. Introduction, of course, the definition of key terms in introduction, and just to give you context, like the proper context to understand nutritional genomics better. Okay, the central dogma of life. We will be reviewing this one because I know that you have already finished courses on biochemistry, on basic biology when you were second year or first year, or when you were in senior high, di ba? So I will review the salient points, because in order to better understand or to better appreciate the nutritional genomics as a tool for good nutrition, no, we have to define the key terms, and we have to understand them, because usually ang kahitabo, no, when we were taking those courses, ato lang mag-memorize lang ta, but we do not really understand them wholly. Okay, so my goal here in this part is to really make you understand the terms. Okay, and then nutritional genomics, we have nutrigenomics, nutrigenetics, and nutriepigenomics. So there are a lot of sub-sciences under the nutritional genomics, but I will just be talking about the three main sub-branches. We have nutrigenomics, nutrigenetics, and nutriepigenomics. So I will be defining those branches of nutritional genomics and some applications and some examples para ma-facilitate nato, no? Whether you really understand the topics. Okay. So for the introduction, okay, we have these 5 basic tenets of nutritional genomics. This is according to Farhua et al. In 2010. Okay. So our discussion will be revolving around these 5 basic tenets. So the first tenet is common dietary chemicals act on the human genome. Okay, either directly or indirectly to alter gene expression and or structure. Okay, so what is genome? It's actually the totality of the genes that we have. Okay, in a human body, we have thousands of genes, and these genes are responsible for the makeup of the body, the physical makeup of the body, the functions of the body. Okay, the physiology really depends, ultimately depends on genetics. Okay, and the genome basically, makes up the whole of you. Okay, so again, it's the totality of all the genes that you have. Okay, that's how you define genome, no? And genome can be affected by the environment. Okay, this is the common misconception, no, among people, that genes, that the genes cannot be affected in any way. Okay, like for example, ingnan ka nganong inana imong behavior, or nganong you have diabetes, then ang usual nga response sa mga tao, no, is tungod na siya sa genes. Okay, so is that true? Is that true at all? To some degree, okay, genes take part in for example in the etiology of diseases, no, but it's not the 100% cause. Okay, there are other factors that contribute to the occurrence of diseases, for example. And aside from genes, diet plays a very important role on health and disease. Okay, and diet can affect genes, either the structure or the expression. When you say genetic expression, it's the conversion of the information that is found in the DNA to proteins, which are responsible for the phenotype. Okay, so genotype, ang sanang genotype? Genotype is the genes, your genes. Your genotype comprises of your genes. Okay, mao nang mga sequence nga makit-an sa imong DNA. Okay, what about phenotype? Phenotype is the result of the expression of that genes. Okay, and diet, individual nutrients can affect the degree of genetic expression. For example, if deficient ka ani nga vitamin or deficient ka ani nga mineral, or for example, you are following this certain kind of dietary pattern, for example, you are following a keto diet, naana siya epekto, no, sa what's this, sa level of expression of genes that are responsible for clinical outcomes, for health outcomes. Okay, so I will be citing concrete examples later on, but yeah, that's basically the first basic tenet. Okay, or even the structure. Okay, For example, if you are following a high fat, high carbohydrate diet, that is linked to increased production of reactive oxygen species or ROS. ROS, kung layman's term, what's that? It's, the free radicals. Okay? So, mas daghan ang free radicals nimo if ga-follow ka ana nga diet. Okay? So, what is the effect of ROS? Of course, negative yung effect, no? Because they are free radicals. They, oxidize and damage our cells. And mauna siya ang dahilan sa a lot of diseases and even aging. Okay? Many studies have shown that increased ROS production in the body contributes to accelerated aging. Diba? So these ROS destroy the structure of the DNA, and that would cause mutations, DNA mutations, and DNA mutations are the usual cause of cancer and other diseases, diba? So they do not just affect the level of expression of these genes, but they affect the structure mismo, the structure of the DNA, diba? So that's how potent the effect of nutrients and diet, no, to the genes. Okay. So basically, naagid epekto ang diet sa atong genes. Okay, so we can really say that we cannot really separate the genes from the diet, like essentially speaking, because they are interconnected in this way. The second tenet is, under certain circumstances in some individuals, diet can be a serious risk factor for a number of diseases. Okay, so this tenet basically means that there are people who are at a greater risk of developing cardiovascular diseases. Morning maingon tanong kung tan-awon nato biologically speaking, dili ta equal. Okay? Kaya nga naman, naiuban gid nga mga tao nang tungod sa ilang genes, tungod sa ilang genetic makeup, they have higher chances of developing diseases. Okay? That really explains nganong kani siya nganong nagka-cancer ni siya, nganong nagka-cancer ni siya, then ako parehas raman mi og lifestyle, sige bilar, sige kaon og simple sugar, sige kaon og saturated fats. But nganong siya nagka-cancer, ako wala. Okay? That's because of the differences in the genetic makeup. Siguro there are certain genes in that person, no, who later developed cancer that gave them a higher chance of developing, for example, cancer than you. Okay, so we will discuss that later. So if, for example, that person nga nga mas taas og chance nga magka-develop og cancer, if nakabalo siya first hand nga based sa ako ang genetic results na ako'y higher predisposition to cancer. So di ba mas mag-amping siya sa iyang lifestyle tungod kay siya nakabalo na siya daan nga at a greater risk siya of developing cancer, di ba? So that can be, a potential intervention. Okay? That's one of the applications of nutritional genomics. Okay, so that's a second tenet. The third tenet is, some diet-regulated genes and their normal common variants are likely to play a role in the onset, incidence, progression, and or severity of chronic diseases. So we are unique. Okay, like each of us is unique, genetically speaking. Okay, lahi pila ta ka billions of people around the world. And each of us has different genetics, no, compared to the others. Okay, why is that? Okay, and that would imply, no, that we would respond differently to the same, for example, to the same kind of diet, because lahi man tag genetic makeup. Okay. Although strictly speaking, we are alike like 99 point something sa atong genes, but bisag ka ng gamay nga nabilin, dako na kayo nga variation. Okay, kanang 1%, for example, kanang 1%, dako na kayo nga variation, no, among us. And enough na to make us respond differently to the same stimulus or to the same diet, for example. Okay, so like ni siya, dili ni siya about sa virus nga variants, but for example, I have this gene for the production of lactase. Okay, lactase is an enzyme. Okay, the same sila nga gene, like the same akong gene sa lactase with the others, but na ay variation diha ang gamay, like single nucleotide lang. That's what we call single nucleotide polymorphism. So I will discuss that later, no. Although same sila, but na ay gamay nga variation, di ba? Does that make sense? Pareha sila nga gene sa function. For example, lactase, that is to digest lactose, pareha sila in function, but structurally, naay gamay nga variation. Okay? So, mao nang pasabot aning number 3, no? Nga lahi-lahi ta, maglahi-lahi ta og kanang kuan, no? Like structure sa genes, the same lang ang function, no? Pero ang degree siguro sa function maglahi-lahi tungod sa kaning gamay nga variation sa atong genes. Okay? And that would explain why this person has a greater risk of developing this kind of disease. Tapos ako dili. Okay. Number 4, the degree to which diet influences the balance between healthy and disease states may depend on individual's genetic background. Okay. And lastly, dietary intervention based on knowledge of individual nutritional requirements, nutritional status and genotype can be used to prevent, relieve, or cure chronic disease. So number 5 is the application of these concepts. Okay. So hopefully tomorrow sa application na nga part, no, maka-attend yapon ta para ma-fully appreciate na to ang science of nutritional genomics. Okay. So this is like one of the illustrations that I will show to you. So the effects of diet and effects of foods, okay, can alter, no, the susceptibility of individuals to diseases. Okay, so if your diet is basically, if your diet is healthy, then that is linked with better health outcomes, di ba? Mas baskog ka, mas less ang chances magka-develop ka diseases. Okay, so I will cite specific examples later on. Okay, and there are biomarkers that are to be measured, that are assessed, no. Okay, this could be like a part of our nutrition assessment, genetic data. Okay, asa ka siya mabilong dito sa biochemical, no, but who knows, basig maka-create another domain for nutrition assessment, no. This science is relatively young, so wala pa kayo siya sa mga textbooks nato, no, but in the future we might be, we might be encountering genetic data as part of the domains in nutrition assessment. And from that data, we will be able to know what is the best diet for that person. Okay, so di ba, tailored genetically to the person. That's the meaning of personalized nutrition. Okay, kaya ilahi man tag, ilahi man tag genetic makeup, di ba? So why not develop a tool that would allow us to utilize this kind of data? Okay. Anatomy of gene-diet interactions. Okay, so clinical phenotypes. Okay, again guys, the definition of phenotypes, that's the outcome of genetic expression. Like for example, the gene for the blue color is kani buot-buot ra ko ha, but for example, para lang masabtan ninyo. For example, ang tawag ani nga gene is CY2. So that's the name of the gene that is responsible for the blue color. So that's the genotype, the CY2 gene. What about the phenotype? The blue colored eye. Okay, that's the phenotype. Okay? So, kung unsay ma-manifest physically, that's the phenotype, or unsa ang outcome, that's the phenotype. So, for example, unsay pasabot sa clinical phenotype. For example, you are at a greater risk of developing diabetes. So that's your clinical phenotype. Then what is your genotype? Your genes, because you have these genes, that would predispose you, that would give you a higher chance of developing diabetes. So that's your genotype. So the question is, how will we utilize this nutrigenomic knowledge to at least lessen our chances, or to delay the onset of disease, or the best if matreat yun nato ang disease bisag pa naatay genotype for that disease. Okay, so nutritional genomics offers a very potent tool to do that, to enable us to do that. Okay. Yeah. Okay. We will also be defining the term epigenomic later on. Okay. So we have these factors, that are considered in precision nutrition. Precision nutrition is like another term. Hello. Am I still clear?
Yes, sir. Loud and
Okay.
clear.
Oo. Naamang good nag-open og mic, no? So anyways, so these are the factors that are involved in precision nutrition, and this would give us, or this would enable us to manage these diseases. Okay, so if we factor in all of these variables, then we can do this precision nutrition. This will be discussed more tomorrow, on the application of precision nutrition. Okay. So what is personalized nutrition, guys? So that is different from population-based dietary recommendations. Guys, that of course you are BSND students, and majority of you, the professionals here, are also R&Ds. We know, guys, that we have 3 main subfields of nutrition and dietetics. So 2 of them are community and clinical. So when we are dealing with the community, or when for example gusto ninyo mahimong community nutritionists, we are more on the population-based dietary approach. Okay, like the level of the application of nutrition is on the population level. Okay, we are more on the population based side of the study of nutrition and dietetics. But when we are in the clinical setting, personalized dapat, case to case, or individualized nutrition. Okay, so that's the difference sa atong field. Basta community, more on population then sa clinical, more on personalized nutrition. Okay, population-based dietary recommendations. So what are the examples of population-based dietary recommendations? Pinggang Pinoy, the 10 commandments, those are population-based dietary recommendations, and those are frequently encountered in community nutrition nga field, di ba? Okay, so my question is the Pinggang Pinoy applicable to all individuals? The answer is definitely not. Okay, population lang siya. Okay, the 10 commandments and Pinggang Pinoy are made in order to prevent diseases in the population level. But if i-apply na ng imo case-to-case basis, it might not be effective anymore. Okay? So therefore, when we deal with individuals, that's already clinical. Okay? Because we are dealing with individual patients. Okay? And when we deal with individual patients, these population-based data recommendations would not be that effective anymore. Okay? So, nutritional genomics can give us an avenue to personalize nutrition. Okay? Because again, i-tailor siya sa imuhang genetic makeup. The recommendation that we are going to give to the patient is tailored to your own genes. Okay? So that ang result is precise. That's why it's termed as precision nutrition. Okay? So aside from nutritional genomics, there are also other fields that are involved under the personalized nutrition. We have the study of the microbiota, okay, the interaction between diet and the microbiome. That's a separate topic, no? Okay, but dako pud kayo ng impact ang microbiome. So that's a topic for another webinar. Okay. Yeah, so general nutrition recommendations sa population siya. Okay, but personalized nutrition is adapted to an individual disease risk, lifestyle, and dietary preferences. This is the answer to the question nganong lahi-lahi man ang response na sa tao given nga same lang ang ilahang diet. Say for example, kanang parehas raman ning dakog kaon pero nganong siya kay manambok tapos ako kay diit ko manambok, so nganong kaha? Okay, so nutrigenomics may answer that. Okay, yeah, so for example, kaning pinggang Pinoy, would that be applicable to a person with epilepsy, especially with a child with epilepsy? No, because you know that epileptic children are recommended or a keto diet is recommended to these epileptic children, no? Which deviates from the pinggang Pinoy. Kaya pinggang Pinoy kay ang macronutrient distribution is taas yun ang carbohydrate. But when you say ketogenic diet, mas taas na ang fat. Diba? So, that's the distinction between population-based nutrition and personalized nutrition. So, personalized diet, aside from nutritional genomics, napay other factors like the culture. We must take into consideration the culture of the person. Okay? Diba? Dili man ta pwede nga maghatag-tag diet nga deviate sa iyang culture, sa iyang religion, diba? So we must consider those factors also. The food intolerance, although this can be affected by the genes, okay, like for example, you are intolerant of this food, na siguro na genetic factor. Allergies. Okay, kaning physical activity, no, this might be an entirely different factor, no, from genes. Okay, we must take into consideration the level of physical activity of the person that we are dealing with. Okay, history of diseases, family history. Okay, all of these factors must be considered in order to give a personalized diet. Okay, precision nutrition plate. Okay, so this is just a model, no, in order to show what precision nutrition plate is. So I guess Sir Jacus will be discussing more about this, especially on how we apply this one. Okay, so that's it. So that's I hope naana mo yung context, no, proper context sa pagsabot kung unsa ning nutritional genomics. At this moment, we will be reviewing the central dogma of life. Okay, this is very important para masabtan nato ang mga examples nga akong i-give later on. Okay, what is the central dogma of life? That's very simple. It can be illustrated by this figure. Okay, it's just, you know, the flow of genetic information from DNA to protein. Okay, so all of the proteins that are found in our body, the production of those are dependent with our genes, because these proteins make up who we are. Okay, enzymes. What are enzymes? They are proteins. So therefore, the production of enzymes in our body is dependent with the genes. Okay? So it's our genes. Okay. Unsa ang chemical structure sa genes? DNA. Okay? So it's our genes na that would dictate how is this protein produced. Okay, and or what protein will be produced from this gene. Okay, so, but before the information from DNA is ultimately converted to protein, muagi sa siya in the form of RNA. Di ba? Okay. So these are the key terms that we must understand. Okay, so yeah, what is a gene, guys? Unsa man din ng gene yun? Gene is a segment of DNA, a segment in the chromosomes. Okay, you know that this is a chromosome. And we have pila man ka chromosomes. 'Di ba? Nag-review na ta. 23, 'di ba? Kay pila man 46 man ato ang chromosomes tanan, but we have 23 pairs of chromosomes, so 46 tanan, 'di ba? And that chromosome is numbered from 1 to 23. Ang last mauna ang sex chromosome nato. So sa babae, XX, sa lalaki, XY. Okay? Inside these chromosomes, naadi atong genes. Okay, like for example, this one. For example, mauni ang gene para sa blue nga mata. Okay. Mauni, o for example, mausad ni ang gene para sa lactase, para makadigest ta gatas, di ba? Or mauni ang gene para sa imuhang behavior. Yes, our behavior is can or maybe dependent on our genes. Okay? That's another type of phenotype, no? Kanang behavior nato. Okay, so that's just coming from our genes. Okay, so that therefore daghan tag genes, guys, kay taas man ning chromosome kaayo. If atuan na siya straighten, taas kayo ang chromosome, no? And there are genes that are small, there are also genes that are large, di ba? Those small genes kay gamay lang nga nucleotides, so gamay lang nga DNA. But kato mga large genes, pilato sila ka nucleotides long. Okay? For example, insulin. Okay, si insulin, you know that insulin is a protein. It's a hormone that is a protein in nature. So, the production of insulin needs a gene. So, naatay gene for insulin. Okay? So, if defective ang atong gene for insulin, so siguro mauna ang cause of diabetes. Diba? Like some type of diabetes like DM type 1 maybe. Diba? So, hinana na siya. Okay? So, another illustration of gene is like this. Okay? So, this is, you know, the length of the chromosome, and this part is a single gene for a single protein. Okay? So we have thousands of genes nga naa sa atong chromosomes. Some are unidentified, some are yet to be identified. Okay, so that's why the science is evolving from time to time, because not all genes are discovered yet. Okay, so this is another illustration of how genetic information flows from the DNA down to the production of proteins. So your central dogma of molecular biology is composed of 3 steps. We have replication, transcription, and translation. Diba? Ang replication, guys, it's just unsay pasabot sa replication, maghimo lang kag copy. So mura ra kag mag-photocopy. Kumbaga sa ato nga term, mura ra tag mag-xerox. Di ba? For example, if we want to photocopy this gene, so we do replication. Okay? Why do we need to do replication? Because the cells are dividing. When we are growing, the cells need to divide. So that's cell division. Di ba? Okay. And are we able to grow without cell division? No. And what are the factors that could affect cell division? Primary factor is nutrients. Okay? DNA replication cannot proceed without nutrients. What is this vitamin that is responsible for, the production of bases that are needed for DNA? B9, di ba? Vitamin B9, folate. That's a very important coenzyme in the production of DNA. Okay? So what if the mother has a low folate diet, di ba? Or is having a folate deficient diet? Kasi may tabo. Okay, that's spina bifida. Diba? That's one of the neural tube defects which is spina bifida. Okay, incomplete ang closing sa neural tube because the body or the fetal body cannot sustain anymore the cell division because kulang ang folate. Okay? So that's how important DNA replication is because kinahanglan og DNA replication para mag-grow ang tao. Okay? Para mag-divide ang cells. Okay? So that's replication. That's just DNA to DNA. That's just in order to maintain that you have really these copies of genes in every cell that you have. Okay. But unsaon nato pag-produce og proteins lugar? Okay, before that, moagi sa siya in the form of RNA. So you have to convert DNA to RNA. So that's transcription already. So that's the conversion of DNA to RNA. Okay, I do not want to talk about the specifics of the differences between DNA and RNA, especially in the molecular level, but dali raman, di ba? Like for example, si RNA, that's unsa ba? Na siya uracil or wala, di ba? Yeah, na uracil si RNA, no, DNA does not have uracil. Okay mo? That's just a few of the differences, no? Okay, between DNA and RNA. But it has to be done, okay? Because it's a part of the central dogma. Okay, so this RNA, guys, is just a copy of the DNA. Okay, the structure might be different already, but the information is the same. For example, the body has to create lactase. Sige, si lactase ato ang example ha para masabtan nato. There is a need to produce lactase. So the gene for lactase must be converted to RNA. Okay, like kanang information nga need para makaproduce ng lactase na asa kaning nga gene, so it has to be converted to RNA. Okay, so that's transcription. Okay, the final not really the final, no, but if ato lang siya i-take into consideration ang tulo, then that's the last step, which is translation. Okay, that's the conversion of RNA, the information in the RNA to protein. Okay, so diri na ta makaproduce og lactase, which is an enzyme. Okay, so remember this, di ba? Para mas masabtan ninyo. Giunsa lugar pag-convert sa RNA to protein tungod aning mga codons, di ba? Like mao man ni ang information nga naa sa mRNA nimo, di ba? Makaproduce naman tag mRNA after transcription, di ba? Hello? Okay. Am I still clear?
Yes, sir.
Okay. Yeah, so for example, this is an RNA or an mRNA, messenger RNA. Kay mao ni ang final product sa transcription. Okay. What are these? Very familiar, di ba? These are amino acids. And amino acids are the building blocks of proteins, di ba? Based from this sequence, makaproduce ang atong lawas kung unsa nga protein ang need sa body, di ba? Kung unsa ang magsunod nga amino acid. For example, AUG, that's the code for methionine. Kung ang nagsunod sa AUG kay AUC, so that's isoleucine or ILE. So atong tan-awon ha, naatay, this is the genetic code. Okay. Asa man tong methionine man to, di ba? AUG. So pangitaon nato diri ang AUG. The first letter is diri, second letter man eh. So ang first letter sa methionine kay A man, di ba? Oh. So A, U, second letter G. Okay, the third letter diri, kani ang third letter. A, U, and G. So, asa man na? Asa man si methionine nimo? A, U, tapos G. Okay, so therefore methionine. Okay. What about isoleucine, AUC? So, A, U, and C. A, U, and C. Kay kani ang C man. So, diri. AUC. So, that's isoleucine. Diba? So, actually, it's very easy to identify which amino acid is next if you have a copy of the genetic code. Okay? So, that will just going on hangtod nga naay stop codon. Okay? So, the stop codon is where protein synthesis stops. Okay? So, that's it. So, that's how we produce a protein. Technically, this is not a protein yet because this is just 3 peptides long, 3 amino acid long. So, this is technically a peptide pa, dili pa siya protein, no? But imagine this is your lactase, di ba? Mao ni ang composition sa imong lactase. Di ba? So asa siya nakadepend? Sa code sa imong genes, sa imong genetic code. Okay, so that's translation. Okay? Yeah. So I hope na-review mo ana, no? So that's just, you know, review para as a basics, no? Okay, para masabtan ninyo ang mga terminologies later. Okay, so another illustration of the central dogma is from the DNA to RNA and then to protein with these 3 processes: replication, transcription, and translation. Do not mind this reverse transcription. Okay, only the other kinds of organisms can do this, but we cannot do this reverse transcription. Okay, next is epigenetics. What are epigenetics? Epigenetics happen between or before transcription proceeds, and there are also some kind of epigenetic mechanisms that happen before translation. Okay, such as this one. In order for us to express our genes, the chromosomes must be exposed. Okay, because remember, the chromosomes are tightly packed together, so the genes might not be accessible physically yet, but So how do we uncoil them para ma-expose sila? Okay? Para ma-express sila. Because it's only when they are open, when they are exposed, that they can be finally converted to proteins. Okay? So this is where epigenetic regulation, epigenetic mechanisms take place. Okay? We have this DNA methylation. Okay? This DNA methylation is a kind of epigenetic mechanism. Okay? DNA methylation suppresses genetic expression. When you say suppresses, diba, it does not promote genetic expression. So there will be no transcription, and of course there will be no translation. There will be no production of proteins because of this DNA methylation. Okay. Generally speaking, guys, the effect of DNA methylation is it suppresses genetic expression. That means it downregulates genetic expression. It does not allow this kind of protein to be produced. Okay, but there are cases that DNA methylation activates genetic expression. Okay, but mas pinakadaghan yun ang suppression, no, rather than activation. Okay. Then what is the relevance of this to nutrition? Okay. Naatay this is actually one of the old knowledge about epigenetics, that when the cells of the fetus, of course the fetus is the growing human, no, inside the womb. Okay, if the DNA of the fetus is hypomethylated, then mas taas ang chances nga if mabuhi man galing tong bata, if mas successfully deliver man yun ang bata, that child would be at a greater risk of developing many diseases later on when he or she grows. Diba? So DNA hypomethylation is linked with diets that are low in folate, choline, B12, okay, and to some extent B6. Those are the nutrients that are involved in biomethylation. Diba? Unsa man ang function ni folate, chemically speaking, it gives a methyl group. Okay? Kana siya nga methyl group, it's a molecule, no, that attaches to, for example, in this topic, that attaches physically to DNA, thereby suppressing it. So kung mo-attach si methyl sa DNA, mapugnan ang expression, mapugnan ang production sa protein. Okay? So that's the function of B9, B12, and other methylating nutrients. Okay? If okay, na ay mga genes, no, that must be suppressed para dili siya later on magka-develop og cancer. Like for example, oncogenes. Oncogenes are genes that are responsible for cancer phenotype. So kanang magka-cancer ka, okay? So if imuhang mama kay iyang diet sa una katong nagburo siya sa imuha, low in folate, so hypomethylation. When you say hypomethylation, kulang ang methylation because again, the function of folate is to methylate, di ba? If you have hypomethylation, then that means kulang ang folate. So, dili nimo masuppress ang oncogenes. So therefore, later on, ang oncogenes mas high ilahang chance of being expressed, and that's now the reason of cancer. Okay, di ba? Whereas if the diet of your mother is, is just okay when it comes to folate, when it comes to B12, then masuppress niya tong mga oncogenes. Okay, kay dili man kulang ang nutrients. Okay, so that's an example no, of how epigenetics is linked with diet. Okay, so DNA hypomethylation is generally not good. Okay, it is linked with poor health outcomes. So dapat naisakto nga level of methylating substances, and those methylating substances are your B9, B12, choline, and B6. Okay, and methionine, which is an essential amino acid. Okay. So that's epigenetics, guys. Okay. Usually we talk about methylation, acetylation, and other covalent modification mechanisms. Okay. So yeah. So if the histone, si histone mao ni siya ang magpugong no sa chromatin para dili ma-expose si gene. Okay? So if an epigenetic factor, say for example an acetyl, okay? Unsa ba yung mga acetyl donors ng mga nutrients daghan? Okay? So if okay ang imuhang mga nutrients that are involved in acetylation, then mag-attach sa histone and it would expose this part of the chromosome, and for example this part happens to be the gene that is linked with positive health outcomes. So you're lucky if inana kay na-expose ang gene for better health. So that's why you need this epigenetic factor, and this epigenetic factor is greatly influenced by diet. Okay. So that's epigenetics, guys. Okay, it does not involve the sequence itself, pero ang iyahang gina-alter no kay ang level of genetic expression. Okay. What about single nucleotide polymorphisms or SNP? Okay. So SNPs represent those positions in a genome where some individuals have one nucleotide and others have a different nucleotide, such as this one. For example, this is the gene for alcohol dehydrogenase. Alcohol dehydrogenase is an enzyme that is responsible for alcohol metabolism. Okay, so that would impact how quickly you will metabolize alcohol. Diba? And this would explain why we have different responses to alcohol. Like, hala kani siya kay dali ra siya ma-drunk, dali ra siya mahubog. Tapos kani siya nga tao kay dugay kaayo, taas kayo tolerance, di ba? Mao man na inyong mga istorya. Okay. That might involve the gene that is responsible for alcohol metabolism, which is alcohol dehydrogenase. So for example lang ha, this is the gene for alcohol dehydrogenase. Parehas sa silag sequence tanan. GCA, GCC, GTTAGA, except ani nga area. Except aning single nga area. That's why it's called single nucleotide. Kay mag-differ lang sila sa kaninga nucleotide. The rest in the sequence kay the same na among individuals. Like for example, kani si Karen, si Irish, ug si April. Okay. Lahi-lahi sila nga they have the same gene, which is for for the production of alcohol dehydrogenase. All of them can produce this enzyme, but structurally speaking, lahi na difference, isa single nucleotide ang difference nila. And although isa ra na nga difference, but it has a great impact on their function. Like for example, kung naa kay A nga polymorphism sa kaninga gene for alcohol dehydrogenase, you are fast metabolizer of alcohol. So, kani siya ang taas og tolerance. Mo ni siyang dili kayo mahubog, no? Okay? kinsa ni si April ay si Kwan man to, si Karen man to ang fast metabolizer sa alcohol. Then we have Irish. Okay, si Irish G na siya sa gene sa iyang alcohol dehydrogenase na ay different, no? G. That's, for example, that's the G SNP. Okay. And this polymorphism is linked to slow metabolism of alcohol. So kani siya dali ra siya ma-drunk. Okay. Then si April, okay. Ang yang response sa alcohol kay moderate lang. Okay, like intermediate between that of Karen and Irish. So that's the meaning of SNP. Okay, although naatay tanan ta na ay gene for that, pero naay difference sa single nucleotide, and that's SNPs. Okay, another application of that is this portion. The normal sequence for this gene is this one, G and G. Okay? But sa katong nagka-develop og disease, lahi gyud. Instead of GG, ang naa sa iya is AA. So, nagmanifest sa iya ang disease. Okay? Kaya naaman siya inani nga SNP. Ang carrier, walay phenotype nga disease, like wala siya nagkasakit but carrier siya. Okay, like siguro if mag-minyo siya, then ma-mix ang iyang gene, so dito na siguro sa iyang offspring ma-develop ang disease, di ba? So that's an example. So this is an example of a SNP. Okay, and this is one of the most studied part of the genes, when it comes to nutritional genomics, the SNPs, the presence of SNPs between individuals in a certain population. Okay, there are studies already in the FNRI conducted on SNPs. Okay, so I think Sir Jacques will be able to discuss that tomorrow. Okay. Okay, another example of SNPs, guys, is in caffeine metabolism. Like the marker is SNP RS762551. So this is the gene responsible for metabolizing caffeine. Caffeine is, the main compound found in our coffee. Okay, so that is located in chromosome 15, kani siya nga gene. Okay. So, si individual 1, naa siya'y AA nga SNP. Okay. Then, si individual 2, AC. Then, si individual 3, CC. Okay. And each of these polymorphisms, each of these SNPs is linked with a different response to caffeine. For those who are having an AA SNP in this gene, they are fast caffeine metabolizer. And drinking coffee does not increase their risk of developing heart attack. Okay? So if you have this kind of SNP in your gene, then you are lucky. Especially if you are a coffee drinker. Because even though you are drinking maybe a lot of coffee, it would not increase your risk of developing heart attack. But if you are unlucky because you are a caffeine lover, you are a coffee addict, and it shows from your genetic test nga naadi kay polymorphism nga AC, naadi kay SNP nga AC, then slow caffeine metabolizer ka, and coffee drinking would put you at a greater risk of developing heart attack. So, unsa man ang recommendation sa imo? For example, nagpa-consult ka sa dietitian who is specializing in nutritional genomics, and gipakita nimo ang results sa iya, and the dietitian found out that, oh, you have this kind of SNP in your genetic data. Then, unsa may recommendation? If AC ang SNP nimo, then ang recommendation sa dietitian sa imuha is, okay, kanilang ang imuhang caffeine consumption ha, because you have this kind of SNP in your genes. So, that's an application already of personalized nutrition, di ba? The dietitian is able to apply the genetic data to his or her dietary recommendations, di ba? But if you have an AA SNP, then okay, coffee drinking is just fine for you because you know you have this AA SNP anyways, di ba? So that's an example of how we apply the SNPs. Okay, so I'm explaining this because most of the FNRI studies on nutrigenomics are involving the SNPs. So para okay, nasabtan na nako mao dining SNPs. Okay, so therefore dili siya mahimong hindrance sa imuha nga magbasa because kasabot ka. Okay, I hope nakasabot mo. Okay, so later na amantay question and answer. So I will just clarify your questions if naman galing. And formation of free radicals. Okay, this is the direct effect of nutrients of diet to your genes, sa structure sa imuhang genes, structure sa imong DNA. There are a lot of studies that have found out that if you are chronically taking a lot of calories, especially coming from simple sugars and saturated fats, you have higher free radical formation in your body. And free radicals are bad news because they would oxidize your DNA. They would damage your DNA. Okay, this is not a good scenario. Whereas if you are practicing fasting, okay, if you are practicing low caloric diet, then that would give your mitochondria rest, okay, and that would lessen the production of free radicals in your body, and that would mean that there would be less DNA damage in your body, and that would mean that you would be at a lesser risk of developing diseases. Okay, so I have discussed to you when you have your nutritional biochem that diba, there are some oxygen species that can leak from the electron transport chain. Okay? And kung daghan og foods, daghan og substrates, so daghan pud ang moadto didto sa ETC, di ba? And therefore, mas daghan ang leakage sa free radicals that could damage the DNA. Okay? So there are really scientists that would really recommend a low caloric diet. Okay, or you can do that through fasting, or but again, before practicing that, you must consult a registered nutritionist dietitian for a personalized treatment. Okay, because fasting might not be that good to you. Okay, so other sources of free radicals, we have inflammation, smoking, ionizing radiation, air pollution, and UV light. Okay. There are also some nutrients that protect the DNA from oxidative damage, and that's vitamin A and all of those antioxidant nutrients. We have vitamin E, vitamin C, zinc, selenium, okay, and the non-essential phytochemicals. We have a plethora of phytochemicals that are found in plants that protect the DNA from further damage. So that's why a diet that is high in plants, especially in colorful plants, is a very good kind of diet because that would give us, additional safeguard from or against free radicals. Okay, this one, guys, this would just show you know that there are dietary factors that could affect cell division. This is cell division, guys. Like for example, if you have low of these nutrients, G1 cannot proceed to S phase, and therefore mitosis cannot occur. And you know that mitosis is cell division, diba? It's one of the main it's one of the two main modes of cell division, diba? So mitosis cannot proceed without these nutrients. So diba? So that's how important nutrients are, because growth cannot occur without them. Okay? There are also compounds that are found in your diet, no, that could promote health sa imong cells, like this compounds: curcumin, quercetin, rutin, polyphenols like resveratrol, epigallocatechin, gallate, vanilloids, lycopene, many organosulfur compounds like sulforaphane, which is found in cruciferous vegetables, and isothiocyanates. Okay. So that's it. That's the central dogma of life. Diba? So I hope na review mo no sa katong mga terms. Okay, so let's define na these sciences, no? Nutrigenomics, nutrigenetics, and nutriepigenomics. So what is the difference between nutrigenomics and nutrigenetics? Nutrigenomics is the investigation of how food components modulate changes in gene expression profile or transcriptome, while nutrigenetics is the study of how genetic variations such as SNPs among individuals affect the response to specific food components. So in a nutshell, guys, nutrigenetics is the study of how our genetic makeup affects our diet. And the nutrigenomics is the opposite of that. Nutrigenomics is more on the effect of our diet to our genes. So reverse ang ilahang definition. Diba? So nutrigenetics, based sa genetic makeup sa individual, how would that affect our diet? Okay, so that's nutrigenetics. Whereas nutrigenomics is how our diet and how these single dietary compounds affect our genes. Diba? So bali. Okay? So that's it. That's sa kaning mga definitions, the same ra gyud na sila. If basahon, I will give you the copy of this one, but basahon na nimo maura gyud to ang meaning ato. Okay? Yeah, so nutrigenetics. This is the science that identifies and characterizes gene variants associated with differential response to nutrients and relating this variation to variable disease states, especially cancer. So, it focuses on the effects of our genetic makeup to our diet. Like, how would we adjust our diet based on our genes? So that's nutrigenetics. Whereas nutrigenomics, unsang impact sa diet sa genes. Diba? So, similar sila but different. Okay? Bali. Okay. Kani differences. So nutrigenomics, the influence of nutrients on gene expression. Nutrigenetics is the heterogeneous response of gene variants to nutrients, dietary components, and developing nutraceuticals. So diba, ang impact sa diet, sa genes, that's nutrigenomics. Nutrigenetics is the opposite, the impact of the genes to the diet. Okay. Nutrigenomics would also enable us to formulate associations between specific nutrients and genetic factors, whereas nutrigenetics would explain why different people have different reactions to the same nutrient. Okay. Nutrigenomics provides information about how the foods you choose change how your genes are expressed, whereas nutrigenetics provides information about how how your specific genome should inform what and how to eat to maximize health. So technically, nutrigenomics refers to how nutrients influence your body to express genes. Diba? So ang impact sa nutrients sa genes. Whereas nutrigenetics refers to how your body responds. How your body responds to nutrients because of your existing genetic makeup. So the influence of your genetic makeup to how you eat or to what is your diet. Okay, sorry. So therefore, nutrigenomics is more useful for addressing medical and health issues, while nutrigenetics is more useful to optimize health in general and meet weight, fitness, and body composition goals. Okay. So those are the definitions of genetics and nutrigenomics. What about nutri-epigenomics? So this is just the link between epigenetics and nutrition. Okay, so di ba we talk about ganina about sa epigenetics, methylation and acetylation and other covalent modification regulatory mechanisms. So sige, let's focus on DNA methylation. So DNA methylation is highly dependent on the nutrients that are involved in the biomethylation, which are, you know, B9, B12, B6, and choline. Okay, so if you are deficient of those methylating nutrients, then DNA methylation would not be possible, or there would just be an inadequate methylation, which is called as DNA hypomethylation, and that is not good news because there might be some genes that because wala na mag-suppress sa ila, so they will be expressed, and those genes can, you know, negatively impact the health. Okay, such as, for example, katong akong giset nga about genes that are responsible for cancer, so they must be repressed, they must be suppressed through these nutrients. But if kulang imong diet for that, then ma-activate yun sila, ma-express sila, ma-produce sila, and mauna na sila ang reason nga nung nagka-cancer ka. Okay. Okay, another example of nutri-epigenomics para mas masabtan nato, no, is the effect of food to the destiny of a bee. Okay, so there are 3 kinds of bees, diba? You know that in a colony, you have the queen, the worker, and the drone. Si queen, ang iyahang sole nga responsibility is just to, you know, lay eggs and preside over the hive. Siya ang leader sa colony. Okay, then iyahang work is mag-reproduce, okay, mag-lay og eggs para sa next nga generation of bees. Si worker bee, siya ang tig-keep sa colony, like siya ang tig-produce sa honey, tig-maintain sa structure sa comb. Okay? Siya ang take care sa bee, sa queen bee, siya ang tig-pakaon sa queen bee. Okay? Si drone, siya tong galupad. Okay? Drones are the only males in the hive. So unlike the queen and the workers, drones do not have stingers. Okay? Yeah. So in a certain colony, na ay ordinary lang nga bee dito nga later on mahimo siyang queen bee. So how does the colony decide which bee is destined to become a queen? Okay, that is if this kind of food is present. And what is that food? That is called royal jelly. Diba? So mauning royal jelly nga, if i-consume ni siya sa isa ka bee, mahimo siyang queen bee. Okay, so that's how important food is in the bee colony, because it's this kind of food that would decide which bee is going to become the next queen. So without it, walay mahimong queen. Wala, kung wala ning royal jelly. So royal jelly is like the food to become a queen. Okay, so what is the relation to nutri-epigenomics? The royal jelly works through epigenetic mechanisms. Like kani si royal jelly, naa siya yung mga methylating nutrients diha that would activate the genes that are responsible for becoming a queen. So mudako siya nga isa inani nga size and siya na ang queen bee. Okay? So that's an example of nutrigenomics. But we are not bees, diba? We are humans. But the same epigenetic regulatory mechanisms also occur to us, but lahi lang ang mga outcome, no? Okay? This one, no, it would show you the methylating nutrients like the choline, folate. B12 is not shown here, but B12 is definitely needed in the metabolism of folate. Okay, and to produce S-adenosyl methionine or SAM, which is the ultimate methyl donor to the DNA, kinahanglan og kaning mga nutrients. So these nutrients are responsible for the production of SAM, and SAM in turn is the one that really methylates, that physically methylates the DNA. Okay? So unsa ni siya? If the maternal diet is deficient in choline, okay, that would then lead to lower SAM levels and lower levels of DNA methylation. And what's the phenotype? What's the outcome? Increased risk of child born with undeveloped central nervous system and neurological defects. Okay? So, mo na ni karon nga, if ang maternal diet is low in these nutrients, mo na mahitabo sa bata. Okay? That's the importance of the first 1,000 days of life. Okay? Ngano kani siya forever na ni siya nga naa sa bata. Diba? Wala unta ni naing-ani kung okay ang diet ni mama. Okay, so that's the importance of the 1,000 days of life. Okay. Another example para ana no is this one. If the infant is born with normal birth weight, then this gene is acetylated. Okay, and acetylation of these histones where this gene is found is linked with normal development of beta cells in the pancreas, and beta cells in the pancreas are the cells that are responsible for insulin production, right? So this is normal. Like kung normal birth weight, walay wrong, okay? Like no problem at all. Okay. But there is definitely a problem when the infant is born of low birth weight. Why? Because the gene, this is actually the gene for a transcriptor, for a transcription factor that is needed for normal development of beta cells in the pancreas. Okay? So dili siya acetylated, ang histone kay dili acetylated. Okay? And what's the cause of low birth weight? Poor maternal diet, poor maternal lifestyle. Okay, like siguro ang mama dili healthy ang diet, wala gi-exercise, or nag-inom og alcohol during pregnancy, di ba? Or ga-engage og mga unhealthy lifestyle. So, inani ang mahitabo sa cells sa bata. Okay? And this gene would definitely not be expressed because of this epigenetic mechanism, this epigenetic cause. Okay? And that would lead, or that would make this unfortunate infant to have a greater risk of developing type 2 diabetes later on when he or she grows. Diba? So it's sad that it could have been prevented if the mother is careful, if the mother was more careful when it comes to her diet. Okay. This one, there are compounds that are found in your diet that can prevent hypermethylation, or that can prevent hypomethylation, and that can, decrease carcinogenesis. Carcinogenesis is the formation of cancer. Okay, so the premise is that if your diet is low in these nutrients that are found in these foods, you will become at a greater risk of developing cancer. Okay, uh, mapugnan siguro ang transcription that are responsible for protecting your body against cancer. Okay, so it's just a matter of how your diet is, how good is your diet in, in manipulating the expression of your genes, di ba? So actually it gives us a control nga ay makontrol di ay nato atong genes. Like kung naatay genes kay na, don't worry, na ay diet para makontrol na. Di ba? So it empowers dietitians that ay naadi ay tay inani nga tool. We can use this tool in order for us to become more relevant in the management of diseases in hospitals. Okay, so that's why nutrigenomics is our hope, no, in the future. To better manage, diseases. Sorry. This one, DNA methylation. Okay. This is the level of methylation. This kani siya diri ang high level of methylation, and that's good because DNA must be methylated para ang pregnancy ma-sustain and para ang sperm and egg cells healthy. Okay, para maka-conceive. For example, ang couple. Okay, so need og inani nga level of methylation kani. What about guys if kulang ang imuhang katong nga mga methylating nutrients? So diri siguro nga part. So dili ma-sustain ang growth sa imong mga cells if ang DNA methylation nimo is kulang. Diba? So that's why these nutrients are essential. Okay? Okay, so those are examples of nutri-epigenetic mechanism. So more on kung ano, magisgot tag di na methylation, di na acetylation. Okay, so I have here some working examples, and I want the audience to send a message kung say answer sa katong nga question. Okay. Sige ha, so please participate guys para makabalo po whether you understand the discussion or not. For example, phenylketonuria. So PKU is it's a disorder. It's a single nucleotide polymorphism po, pero disease siya. If nakay SNP that is linked with the phenylketonuria phenotype, then you are very unlucky, no, kay na kay PKU because of that single difference of nucleotide in your gene. For unsa nga gene guys, gene for phenylalanine hydroxylase. So this gene is responsible for converting phenylalanine to tyrosine. Okay, because tyrosine has to be made in the body, because remember that tyrosine is a non-essential amino acid, but the production of tyrosine in the body depends on phenylalanine, which is an essential amino acid. Okay, but what about if you have phenylketonuria? Your phenylalanine hydroxylase would become defective at all, like dili na siya would become non-functional. Okay, or siguro mugamay lang ang iyang activity. Okay, so dili na siya makakonvert sa phenylalanine to tyrosine. So phenylalanine would just accumulate in your blood. Tyrosine would not be produced. So you would become deficient of tyrosine. Tyrosine becomes a semi-essential amino acid for you because you have phenylketonuria. And phenylalanine just accumulates in your blood. And phenylalanine in toxic amounts is very dangerous, and that could mean death, no? Okay. So, so therefore, the dietitian knows, for example, the dietitian knows that this patient has PKU, okay, because of this SNP sa iyahang gene for phenylalanine hydroxylase. So the dietitian recommends to have low phenylalanine diet and to supplement tyrosine in the diet of the child. So na-utilize sa dietitian ang knowledge nga ay kani siya kay di na ni siya makametabolize og phenylalanine. So therefore kinahanglan siya og low phenylalanine diet and high tyrosine diet. Okay, this is the question. This is the question, guys. I want you to type in your answers as a chat box. What is that? What is that example? Is that nutrigenomics? Is that nutrigenetics? Or is that nutri-epigenetics? Go ahead. Sige be. Unsa ba na siya? Nutrigenomics, nutrigenetics, or nutri-epigenetics? Sige, clue. Definitely, dili gid ni siya nutri-epigenetics. So, it's between nutrigenetics and nutrigenomics. So, what's that? Nutrigenetics or nutrigenomics? Okay. Okay. Sige. What about others? Okay. So, many of you got the correct answer. That's nutrigenetics, di ba? Unsa ganang nutrigenetics, guys? It's the influence of the genetic makeup to the diet. So, the genetic makeup is naa siya SNP sa gene for phenylalanine hydroxylase. Okay, that's the genetic makeup. That's the genetic trait. And naka-influence siya sa response, naka-influence siya sa diet, which is mag-adjust ang patient nga dapat iyang diet low na in phenylalanine and high in tyrosine. So that's the effect of the genetic makeup to the diet. So that's nutrigenetics. That's not nutrigenomics. Okay, very good. Nakuha ninyo. So that's nutrigenetics. Next example. Nag-loading na. I don't know. Madunggan pa ko. Nag-loading lagi siya.
Yes, sir.
Dili na lagi ni siya mukuan. Mo next. Okay na. Okay, next one is lactose intolerance. So lactose, okay, you know this already. Diba? This is due to a certain SNP in lactase gene, or in the gene that is responsible for the production of lactase. Okay. And this patient has lactose intolerance. Kaya di siya maka-experience siya og kanang kung ano, malabsorption, magka-diarrhea siya, magka-excessive flatulence siya, magka-stomach cramp siya. Every time she takes milk. So the dietitian recommends to restrict high lactose diet, high lactose foods sa iyang diet. So what's that? Nutrigenomics or nutrigenetics? Hello? What's that, guys? Mag-loading. Mag-loading akong kuan, basta mag-kuan ko sa chat. Okay. Ha? Nutrigenomics? Why? Why nutrigenomics? Can anyone explain? Why is that nutrigenomics? Uy, pag-sure mo ha. It's not nutrigenomics. Okay. Ayaw mo kataranta. Nagdaharamang mo. Nutrigenetics. Okay, kaya ano man, nag-adjust man atong diet tungod sa atong genetic makeup. Okay? Kaya ato ang genetic trait kay kulang atong lactase production. So magka-lactose intolerance yun ka ta kay kulang man ang lactase. Okay? So unsa man imong action to lower your consumption of dairy products. So that's nutrigenetics. Okay? The impact of your genetic makeup to your diet. Okay? Lisod pod nga nakahibalo na kadaan nga imong genes kay inani mag-inuma pa lugar kag milk, di ba? So ang direction is from the genes to the diet. So that's nutrigenetics. Okay. Next is saan eh? Next is hemochromatosis. Okay. A genetic deficiency of a protein that helps regulate iron absorption. If you have this kind of genetic trait, you are faster to absorb, or you have a higher rate of iron absorption than normal people do, or than differently abled people do. Okay. So, since you have hemochromatosis, your dietitian recommends you to avoid the use of cooking vessels that are iron cast. Okay, kana mga made of iron ng mga cooking vessels, dapat ginabawal na. Like the dietitian might inspect your cooking utensils nga dapat walay mga made of iron. Okay, kay paspas man ka maka-absorb og iron. Okay. And the dietitian would restrict you of heme iron. Okay? Kaya nga naman, mag-build up man ng iron sa imong lawas, then mahimong red imuhang kuan. Dili man kayo red si Koya, no? Pero, yeah, mura siya ganang kuan yun. Na siya yung pagka-red gamay. Yeah. Many, many in the community refer to someone who is having or who is affected with hemochromatosis as Iron Man. But it's insensitive to address that kind of patient, no? Okay. So but yeah, I'm just giving you a context, no, nga ang hemochromatosis kay overload of iron in the body. Okay. So mao to ang recommendation ni dietitian. So what's that? Nutrigenetics or nutrigenomics? Di na ako ka-open sa ako ang chat, but the correct answer is still nutrigenetics. Okay? Nag-loading na sad siya, sorry. Next is celiac disease. Ang celiac disease is same ra gyapon, guys. SNP gyapon na siya, no? And so kung naay celiac disease ang tao, dili na siya maka-absorb og mga nutrients, kay mag-atrophy man ang small intestines due to hypersensitivity to gluten. So whenever a patient with celiac disease consumes gluten-rich foods, the small intestines react in a negative way. And one of the reactions would be malabsorption of nutrients. So naturally, you would restrict the gluten from the diet of the patient. Okay, and that's still an example of nutrigenetics. Okay. So I will just leave this to your own reading, guys, because I think we have already discussed this sa ato sa bisag pa katon sa nutrition fundamentals nato, no? And sa, of course, sa nutritional biochemistry as well. So these are just, the functions of nutrients specifically in the DNA involving the genome. Okay? Like B12 and B9 are the methylating nutrients, so they help methylate the DNA. Okay. Zinc and magnesium, essential as cofactors for DNA polymerase, required for nuclear and mitochondrial DNA synthesis. Okay. Vitamin C and vitamin E and antioxidant polyphenols, of course, they protect the DNA against oxidative damage. Folate and B2, B6, and B12, the B vitamins, same. They help produce DTTPs, deoxy, sa kuan ni siya, sorry. Nakalimot ko sa term, but it's definitely a nitrogenous base, okay? Ethymine, a derivative of thymine, okay? DTTP and DUMP. DUMP is deoxyurine monophosphate, I think. Deoxy thymine triphosphate, something like that. Okay, so thymine and uracil are, the bases that form the nucleotides. So if these B vitamins are lacking, then these nucleic acids cannot be formed, so your DNA cannot be formed. Okay, so aside from methylation, these B vitamins also are directly impacting the production of the nitrogenous bases. Okay. Niacin, of course, it functions in the form of NADPH, responsible for synthesis of DNA also. Important in the central dogma. Okay. So superoxide dismutase is a very powerful enzyme that fights off free radicals. Endonuclease 4 is functions in DNA replication and so on. Okay. Iron, magnesium. Okay, so the point is they are needed in what's this? They are needed in DNA replication as well as the other parts of central dogma. Okay. Before I end, guys, let me share to you the an article that I really want you to read. Okay, wait. Wait lang ha. Sorry. Asa man to? Wait lang. Kadjut lang, guys. How do I stop sharing the... Guys, am I still sharing the screen? Sorry,
Yes,
ha.
sir. You're still sharing your screen, sir.
Okay, how do I stop sharing my screen? May control diha. Dili lagi ni. Okay, thank you. Okay, I will share my screen again, please, organizers. Okay. Okay, Nara. So this is an article that I want you to read, but I will give you context on how to understand this article. Okay. So kani siya kay recent pud ni siyang article. This was just published in 2017. Okay. So kani mga examples ni siya sa nutrigenetics, nutrigenomics, and nutriepigenetics. Okay. So for example, this table, Nutrigenetic examples of SNPs diet interactions involved in disease risk. So kani guys, tanan ni sila nutrigenetics. Okay? So for example, this one guys, MTHFR, I think this is a gene that is responsible for the production of methyl tetrahydrofolate reductase, which is an enzyme that is responsible in methylation. Diba? That this is involved in methylation and homocysteine metabolism. Okay? If you have this kind of SNP, guys, where naa kay T, na IT, ang variation sa imuha kay T, okay? Of course, all of us kinatay MTHFR gene. Pero katong mga unlucky ones, kay katong na IT ang sa ilahang na sila T nga SNP. Okay? So, what then? If they have low intakes of folate, B6, and B12, then they are at a greater risk of developing breast cancer. This is according to a study, guys. Kani kay meta-analysis naman ni. So, synthesize na nga mga results, no? So, kani siya guys, mas taas imong risk of developing breast cancer. Maulagi ni siya, this can be this can be used in the practical setting, like the healthcare professional, like the dietitian might ask you to have you, tested for your genes, okay? Especially sa MTHFR nga region, okay? And if the genetic test will show nga naa kay T nga SNP, then unsa may i-recommend sa dietitian sa imuha? Ang i-recommend is be careful with your B vitamin intake, especially folate, B6, and B12. Dapat dili deficient para ma-delay ang breast cancer or para ma-lessen ang chances of breast cancer. Diba? Because if nakay inani nga SNP sa imong gene, then wala ka kabalo nga inana day effect, tapos low imuhang intake sa folate, B6, and B12, then definitely taas yung imong chance nga magka-breast cancer ka. Okay? So that's MTHFR gene. Okay. Another example here is vitamin D. Okay. A gene that is responsible for the production of a gene of a protein that is involved in vitamin D activation in the body. I think this is VDR, the VDR gene. The VDR gene. Okay. If you have a SNP on the VDR gene that says A, then if you have a low calcium diet, then definitely magka-osteoporosis yun ka. Okay? So, what would the dietitian do? I-tailor niya based sa kanang genetic test. Okay. Ikaw kay magkaon dapat kag mga calcium rich foods mo, inom dapat kag dairy products, or if vegan siya then milk alternatives in order to ensure calcium intake. Okay? This is the reason siguro po guys nga nung siya nga nagka-osteoporosis, the same ra mo nga low calcium, okay, same sa isa ra mo ka compound, for example, then na-observe ni mo nagka-osteoporosis siya kay parehas ra mo diet. Nganong ikaw wala ka nagka-osteoporosis? Tungod kay wala siguro kay SNP nga A sa imong VDR gene. That's why, although parehas inyong diet, but lahi inyong response. Diba? So that's what I'm talking about. Okay? What about high carbohydrate diet? Okay. If you have this kind of polymorphism on the TAS1R2 gene, nga G, then a high carbohydrate diet would put you at a greater risk of developing hypertriglyceridemia. Okay? And again, if you are the lucky one and you have you don't have this kind of SNP on this gene, then you would enjoy high carbohydrate diet like much, no? You would enjoy more high on the high carbohydrate diet compared to your companion, no? Because you have a lower risk of hypertriglyceridemia. So your companion is a little bit unluckier, no, than you. Kaya naa siya inani nga polymorphism. Okay? So yeah. So I will not, of course, discuss all of this, but I'm just giving you the context, no, to understand this one. Okay? So these are nutrigenetic examples still. Okay. At kani nutrigenetic trials gyapon ni, so nutrigenetics gyapon ni sila. For example, in the FTO gene, I think this is a gene that is involved in a certain person becoming obese. FTO gene. Yeah, I think so. Si FTO gene. So naa siya inani nga, if that person has this kind of SNP, then a high protein diet would benefit that individual. Because if that individual follows a high protein diet, then that would lead to greater weight loss. Okay, so this is an example of a nutrigenetic application nga beneficial. Oo. Like that's an advantage to you. Okay? So if you have this kind of SNP, then that's good news for you, because if you would just follow a high protein diet, then that might lead to greater weight loss. Okay? So diba, you can see na how we can apply nutrigenetic data on our future jobs as dietitians, diba? Oo. Isa pa. If you have this kind of SNP in your TCF7L2 gene, then you would have smaller weight loss. Diba? So just another unlucky genetic card. Diba? You have been given very unlucky genetic cards. So if high fat, that would lead to smaller weight loss. So a ketogenic diet might not be effective for that individual. Okay, because a high fat diet would lead to just small weight loss. Diba? So sa kaning individual, guys, daily effective siguro, or gamay lang ang chances nga nga mamutaas iyang weight loss. Okay, like dili siguro kaayo effective ang keto diet sa iya. Diba? So therefore, not all individuals are capable of losing weight under a ketogenic diet. Like of course, expected man yun nga mag-lose og weight tungod sa ketosis, but the effect would be much greater in other individuals compared to this person that has this kind of SNP. Okay. For someone who has this gene, then siya SNP inani, if that someone just follows the Mediterranean diet, then lower weight gain. So Mediterranean diet is promotive of health in this case. Okay. So all of those are nutrigenetics. What about nutrigenomics? Okay, mauna ang nutrigenomics na, no? So nutrigenomic examples of interactions between dietary intakes and gene expression profiles involved in disease risk. So unsa gani ang nutrigenomics? That's the effect of the diet to the genetic makeup mismo, or to the genetic expression. So a low protein diet can decrease. Ang expression changes is minus, so decrease kung minus, no? A low protein diet can decrease the expression of this gene, NR1H3. And the disease involved is diabetes type 2. Yes, so if you have this kind of SNP in your NR1H3 gene, and if you are following a low protein diet, then that would increase your risk of developing type 2 diabetes. So this is a nutrigenomic example already, because the low protein diet would lead to underexpression of NR1H3. So mugamay ang production sa kaninga protein. Okay? And that is not good news, to especially if you are trying to, decrease your risk of developing type 2 diabetes. Okay. Same, low protein. Mugamay ang production ani nga proteins. Okay, then same nga disease ang outcome. Chromium deficiency, okay. This would, add up to your knowledge about how chromium increases the insulin sensitivity in cells. Now, remember that chromium is called the glucose tolerance factor, di ba? It does its function by making sure that insulin signaling genes are expressed at a high rate. But if you have chromium deficiency, then definitely these insulin signaling genes would be underexpressed, and kung mawala ni sila ng mga promoting factors, then mugamay ang insulin production, and that's type 2 diabetes. Okay? Selenium deficiency, okay. So that's it, di ba? Nutrigenomic na siya, di ba? Understand? Subtan? Okay. High fat, rich in lard, so rich in saturated fats. Ang effect is OPN, ADGRE1, TNFA, NFKB1 genes. And ma-overexpress, plus is ma-overexpress, and if ma-overexpress pud sila, di pud maayo, because that would lead to obesity-related inflammation and insulin resistance. Di ba? So that's nutrigenomic examples, okay? Because that's the effect of the diet to the genes. Certain nutrigenomic studies assessing gene expression profiles associated with nutritional interventions. So if one is practicing Mediterranean diet and one has these genes, no? Okay, then the effects would be anti-inflammatory and anti-atherogenic. So good ang effect ni Mediterranean diet sa kaning mga genes na to, no? Kaya ang phenotype is anti-inflammatory and anti-atherogenic. Diba? So Mediterranean diet is good. Okay? Because it is linked with anti-inflammation and anti-atherosclerosis. Okay. Curcumin. Curcumin is, asa makuha ang curcumin, be? Asa man, sa mga spices, di ba? Especially cumin. Okay, naapod na siya makuha in small amounts sa ginger and yeah. So sa paprika naaman ni ang curcumin diha. Okay? So anti-atherogenic, anti-cancer, okay? Yeah. Okay. Apple polyphenols, flavonoid fish oil supplement, high N3 to N6 PUFA ratio, okay? Maula gini nga high dapat ang omega-3 rather than high ang ratio sa N3 to N6 kay anti-inflammatory ba ang omega-3, di ba? Genistein. Asa man makuha ang genistein? That's one of the 2 isoflavonoids found in soy, di ba? Together with daidzein, di ba? So they are anti-cancer, okay? Because they impact these genes. Okay? So that's nutrigenomic because they impact the genes rather than the other way around. Okay, what about epigenetics, nutri-epigenetics? Okay. So more on methylation, acetylation, and other covalent modification mechanisms. So a low protein diet is involved in acetylation of an R1H3 gene, and that would result to underexpression of this gene, and that is linked with type 2 diabetes mellitus. Okay. Chromium deficiency, methylation of insulin signaling genes, and that's also involved in type 2 diabetes mellitus. Okay. So, yeah, diba? So, if we just, know the genetic data of our patients, we can tailor what is the genetic makeup of the patient with the best diet intervention for them. Okay, so that's personalized nutrition. Okay, so that's it, guys. So I will not cite all of this. I will leave others for your own reading. Okay, so I will just share this to you. Or you can just, screenshot this one and check it for yourself. Okay. So, balik ta sa, I think, kato naman ata, concluding remarks na dayon. So, I hope guys, I have given you the mindset ba that dietitians are not just found in the four corners of the dietary department of the hospitals. We deserve to be included in the team that intimately manages the patient's diseases. Okay, and I hope that I have shed light on how will we utilize this nutrigenomic data, this nutritional genomic data, in order to promote personalized nutrition. So I think that ends my presentation, guys. And I really hope that nakaspark ko og interest sa inyo to pursue this discipline when you graduate and when you have that license, because this is an emerging science. The FNRI would we will expect that the FNRI would conduct more studies about nutrigenomics. Okay, and I hope you will still attend. You will be required to attend tomorrow, to listen to the topic of Sir Jacques, who is an FNRI employee. Naa siya mismo employed sa nutritional biochemistry section sa FNRI. So we are very privileged that he accepted the invitation. So I hope you will really listen to him tomorrow. Okay, so I think that's all, guys. So but before that, now I want to give thanks to the organizers, especially Karil, who is the head of this organizing committee, and of course to our dynamic, funny, talented, and beautiful hosts. So, and to Jenny, Rhea, and to Vince, and to Ayumi, and sorry if ako'y na forgot nga na mention og name. So thank you sa inyo sa pag-organize sa kaning webinar. So that's it, guys. Thank you and have a nice afternoon.
Thank you very much, Sir Wilmar, for that very timely and very informative discussion, sir. And we know nga kami tanan na adjud na learn for this afternoon, sir.
Yes, of course. Thank you very much, sir.
So if you have any questions for the participants, now if you have any questions or clarifications, feel free to comment in the chat box and Sir Wilmar will be addressing it. And if na po may follow-up na questions, you can also raise your virtual hands. So, sir, we have some questions from our G forms. So the first question, sir, is how does different ethnicity affect nutritional needs, Sir Wilmar?
Sorry, wala na ako nadunggan kayo sa to.
How does different ethnicity affect nutritional needs, sir?
How do different necessity?
Different ethnicity, sir.
Hello? Hello?
Sir, am I audible na po?
Okay, yes. Unsa?
How
Ethnicity?
does Yes, po. How
Okay.
does different ethnicity affect nutritional needs?
Of course, different ethnics, people of different ethnics, we would really expect them to have different genetic makeup. Among all of the comparison, sila jud ang murag na ay dako nga difference between them when it comes to genetic makeup. So natay mga examples where our nutrient intervention would be different from one ethnic to another. Say for example, if this patient is of African American origin, so black ang iyang race, no? Okay, na ay African ancestry, and we would of course ang ilahang complexion is black, di ba, which is beautiful. So black ang ilahang skin. Okay, so naay mga certain interventions nga mag-vary. So say for example, the amount of vitamin D, they need a lot more vitamin D compared to light-skinned individuals. Okay? Kaya nga naman, they have a lot of melanin in their skin, and that would mean that they block much of the sunlight, and that would mean that there would be less vitamin D synthesis inside their body. So to make it up for that, they need to consume more vitamin D. Okay, because they are more prone to becoming deficient in vitamin D. Okay. There are also some ethnic groups that are accustomed to this kind of diet. So if other kinds of foods are introduced to them, they would develop intolerance, no? Or they would become more at risk of developing diseases. Like for example, in the US gihapon, there are ethnic people in the north, the Eskimos, di ba? Their diet is, of course, since they are in the north, they are in an icy environment, so their diet is just composed of meats from polar bears, from salmon, from fish, and from seals, di ba? And their diet is very little when it comes to simple sugars. There are studies that if these Eskimos are fed with high sugar diet, no, their risk of diabetes greatly increases. So that's how nutrition is different among ethnics. Okay. Here in the Philippines, I don't have much specific examples to cite. Like for example, like unsay difference sa Bisaya sa Tagalog, no, when it comes to metabolizing nutrients. But if wala pa yan ang research, then that's a potential research topic for you, for future dietitians like you. Okay, that's it.
Thank you, sir, for that answer. We have another question, sir, from the form. Here it goes. Is nutritional genomics effective and helpful in the determination of diseases and or conditions? Again, is nutritional genomics effective and helpful in the determination of disease and or conditions?
I think this was addressed already, di ba? Would you agree? I was able to address this already in our topic, di ba? Again, if you have nutrigenetic data from your patient, to like the SNPs on certain genes that are nutritionally relevant, then from that data you will be able to tailor that genetic data with the best nutrition intervention for that patient. So by utilizing the nutrigenetic data, we can really come up with the best nutrition intervention for the patient. Okay, so that's it.
Thank you very much, sir. So we have a question from Ms. Cheryl Custodio. How does stress affect our genetic makeup, sir?
Okay, what I know, I think there are a lot of mechanisms that could negatively impact, that stress could negatively impact the DNA, but or the genetic makeup. But what I know is stress is linked with higher production of free radicals in the body, and that would destroy the DNA, the integrity of the DNA, because this can oxidize the DNA and damage them. So that's one of the ways that I know that the stress can negatively impact the DNA. And another mechanism is stress could induce higher levels of cortisol. Okay, because you know that when someone has high cortisol level in their blood, that means they are stressed out. Okay, like they are experiencing emotional or even physical stress, no? So unsay effect, of course ang effect sa tao kay mag-binge eat siya, okay, or mamayat siya, di ba? So stress is not really a good thing, and it really could affect the DNA, the integrity of the genes.
Thank you, sir, for that answer. We have another question, sir, from the form again. Can nutritional genomics help in combating issues in society such as obesity and malnutrition?
Again, I think this was addressed already from the talk, but I will reiterate. Yes, we can use this as what I have shown to you, that article. There are a lot of genes that when they respond to a certain kind of diet, that would put you at a greater or at a lower risk of developing obesity and obesity related diseases. Okay, so I told you that nutrigenomics can be used as a tool for healthcare professionals like dietitians to be able to better manage patients. Okay, so if we will just have, if nutrigenomic tools, or if nutrigenomic testing would be possible in the near future, then that is really a good news to us, because from that time we will be able to promote personalized nutrition. Okay, and I believe we'll be better in combating malnutrition and obesity in the society.
Thank you very much, sir. If there are more questions, guys, please comment it down in the chat box below. And then you can also raise your hand if you have any more follow-up questions. Thank you.
Kung dili daw ka mo mag-question, guys, si Sir Wilmar daw mag-question sa inyo.
Oo.
Essay daw ang kuan. Essay daw kay gusto ni sir.
Naay ka ng Google Form mismo.
Hala.
Naka-prepare ko, charot. But kidding aside, I hope nasabtan po ng mga basic terms. Kung mao ba yan na ang mga terms na gamito ni Sir Jacus tomorrow. Ha? Oo, mas important yun nga maka-attend tomorrow kay external ang atong visitor, no? So, yeah.
Okay, so I guess there are no more questions, sir. So at this juncture, may I request Sir Wilmar for the giving of the certificate. I'll read to you the citation. A certificate of appreciation is proudly presented to Wilmar June O. Elopre, RNDPG Cert, in recognition for his invaluable contribution as a keynote speaker in the first session of the webinar series conducted by Batch Beta Glucans in partnership with the Philippine Association of Nutrition Alpha Pi chapter titled Nutritional Genomics, the Path to Personalized Nutrition held via Zoom, given this 13th day of January 2022. Signed by Ron Angela G. Rillion, SND PANAP Chairperson, Wilmar June O. Elopre, RNDPG Cert, PANAP Advisor, Marivic B. Lazar, RND-MSc, PANAP Advisor, Alan May N. Marapaw, RND PhD, Chair, Department of Nutrition and Dietetics, and Mylene A. Anwar, PhD, Dean of College of Human Ecology.
Thank you again, Sir Wilmar. So let me request all the organizing committee to have a photo opportunity together with our speaker, and also to our PANAP President, Ms. Ron Angela Rillion. And I am also requesting our professors that are here to please turn on your cameras for the photo op.
Okay, mag-smile na? Or
Yes,
mag-view
sir.
pa? Okay.
Sige, in the count of 3, 1, 2, 3.
Okay,
Another-
at this moment, ay, sige go. Another one.
Okay,
another
okay na,
one.
Vince?
Okay.
I guess you're okay. Thank you, sir. Thank
At
you,
this
Vince.
moment,
Thank you, sir.
no, may I request everyone to please turn on your cameras for our photo opportunity. So, ipugong na to atong mga smile,
Smile,
guys.
yes. Pakita atong best
have-
smile, pero for
Oo.
mga 20 seconds.
1 minute gyud ako no kay 7 ka screens.
Wow, very daghan gyud data ay.
Okay, first screen. Smile lang mo tanan ha. First screen, 1, 2, 3, smile. Next screen, smile na pod.
Next screen, smile. Next screen. Next screen na pod, smile. For the last screen, I guess, smile. Okay, thank you.
Okay, pag smile lang yapon mo, guys. Smile lang yapon. Charot! Okay na bitaw.
Hindi mo lang kay klaro. Basig na eh.
Sorry.
Nag-lock na lang joke.
Ay, sorry. Ay, malaki mag-smile na sila per may partner.
Yes, of course. So, karon partner, since we are done with our talk, let us be entertained by another intermission number. Wow! Given by Miss Elaine Amor Shonko, a second-year student of BSND. Virtual applause, please.
Okay, you may also type in your shout-outs in our comment box kung gusto mo mag-shoutout. Grabe, partner.
Wow,
Na-feel jud na ko dito, partner nga. Mura ko
partner,
giduyan.
kahilakon man sab ko, oy.
Grabe ko
Ay,
bugnaw.
makapangita man sab ka holding hands ani. Oy, hawakan mo aking kamay. Kinsa man
Ana lang ta, partner. Ana lang.
Ana na lang, sige, ana.
Ana lang ha. So, thank you very much, Elaine, no, for that very kanang makapanimbawat balhibo nga tingog. Ako
Ay,
nabasahan
partner.
ganina nga. Grabe jud ang NB. Dili lang daw ako no brains, beauty, but appeal jud ako no talent.
Of course. Bonus gina, partner.
Yes naman, partner.
Yes. Na broken kalit daw from Miss Janicel. Agoy,
Uy.
Jing.
Kinsa
Kinsa
tong
man-
manager ni Kuan? Kinsa tong manager ni Elaine dire? Guy, kayo, oy, na-broken daw si Vince.
Hala, oy.
So,
Kaloy
ayun,
ko.
grabe.
So, before we end this webinar, partner, I guess, manatatanan, di ba?
Napa, partner? Di mo mag-goal.
Hala.
Dapat ipahatag nga Gcash dire. Uy, noon sa ba?
Agay! Abi ko gumanak eh. Ato tanang ibulsa. Oh, di
Ay, dili pwede mo
Ay,
sa
sorry.
partner. Kaya na liquidation
Okay, before
after.
we end this webinar, partner, let's have another game.
Okay, our pakulo is very easy, no? Kung naminaw mo sa top ni Sir Wilmar ganin og ayo, maka-answer jud mo. So, Ange,
Yes, easier kayo na tong game, partner, oy. We will be flashing questions related sa ato ang topic gaina, and ang una to type down their correct answer, of course, will be the winner. So, partner, since sure jud ta nga naminaw silang tanan, ang atong dawaton nga answer kay essay. Aw, dili ay, sorry.
say na jud partner.
Sorry. Guys, simple rin siya. Simple question and simple answer lang. Amo ang
Okay.
dawaton. So, of course.
Let's start,
Okay, let's
partner.
First question. This provides the codes for enzyme and other protein synthesis which heavily affects body functions. Sabi ni partner.
Ikaw magsaba, partner, ay.
Partner, wag siya kabalo ka. Nagbasa na punta, partner. Promise.
Wala sa mong answer kay
Guys, natahasan namin nga
Answer.
basahon ni nga question. Sorry kaayo. Hindi makakatawihin.
Okay, answer na ta. Oy!
Send answer.
Send of answer. Ano
Sorry,
siya,
Ate Car.
Karen?
Nagbasa
Oy!
na me.
Ayun! Ano ko yung nakita? Okay, congratulations to our first winner, Trisha Espirito.
Thank you. Let's reveal the answer. Oh, jeans. Wow.
Ano
Muna siyang suoton ba?
Really partner. Letter
sorry,
G ko na
sorry.
so good.
Lahi din.
Lahi
Sige,
ni,
sige.
lahi.
Next go. Next.
Next question. This is a type of nutritional genomics wherein the process of how genetic variation affects the body's nutrient response is the focus.
Saka ni partner. Kabalo ka ni partner?
Wala, takiwan.
Nagbasa lang
Ano
kita,
dapat
partner.
kabalutaan ni
Oy.
Sir Wilmar.
Uy, dalian na answer. Uy.
Nagsunod pa bitaw lang answers.
Okay. Nanatay winner, partner. Grabe, paspasa ato, uy. We have a winner.
Congratulations!
Mitchell Clavicilias from Batch Beta Glucans. Wow.
Nagsunod gid sila ni Lot.
Gani. Guys, kung kinsa daw dili ka tubag, willing daw si Jel ang prize.
Uy! Ibaligyan ko bitaw.
Atong i-reveal ang answer. Nutrigenetics. O, di siya partner.
Yes. Okay, next question to partner. Kay gusto na lagi ni sila G-Dash.
So, okay, next question. This is the branch of science that aims to understand how food, nutrients, and compounds found in food impact gene behavior.
Partner, minus 10 daw tayo na si Sir Wilmar. Yo,
Sir,
sir.
sorry, Jud kaayo, sir. Kasi branch of science, partner, biology ni.
One partner. Basig. Calculus. Ay!
Ahay!
Dili
Partner.
din sa yan.
Kidding aside, na natay winner.
Ay, naanak. Kapaspas ba?
Yes! Ana siya kadali, ana siya ka. Grabe ka, ihang mind, oy. Grabe ka, dali kay makatype iyang kamot. So,
Ano
atong
kayo?
winner, congratulations to Felix, nga walay surname, Sir Felix. Kung sino ka dyan, kaway-kaway. Okay, partner, ang answer
Lagi
is
ko sa gitchat ni Ate Karen.
Nutrigenomics. Wala ko kita, unsa.
Perfect ako no kayo ang hosts. Oy, unsa ba di? Ay!
Ate Car!
Ate
Dako
Car!
maning
Ate
atay.
Car!
Please lang. Okay, next.
Next question. This is the type of nutritional genomics that is more useful for addressing medical and health issues. Ka ni partner. Dili ta maging ano dito ka partner kay man.
Kabaluta, partner. Ang
Kabaluta
kabalo
ni
ko.
partner.
Kasi
Sir,
ako
di lang
gusto
may
siya.
magsaba.
Dili mo magsaba kay bawal mag-good.
Uy!
Okay, comment down your answer. Kinsa kay daog. Okay, naanay. Oh, grabe. Nanay. Winner, partner.
Diretso partner. So
Grabe.
congratulations to Rain Gabaysen.
Wow, again from Batch Beta Glucans, sir. Plus points kay Batch Beta Glucans na daog. Wow.
Kami lang ang magtas.
Kami mag-claim sa prize. So, abang-abang lang, guys.
Okay, I think last na rin ito na question.
Yes, ano na dyan? A. amylase daw from Ate Car. To Ate Car, this is for you. This is a single gene disorder that is characterized by gluten intolerance.
Uy!
Wow.
Paspas kayo!
Grabe, nagbasa pa lang ko na niya naka-answer. Uy, wala nga gibasa. Wala na ako nagbasa.
Congratulations,
Congratulations to Jan Rose Bunayok again from Batch Beta Glucans. Alright, hapot ko di ba?
Grabe Grabe ang paghakot na. Mahinay pag ninyo, oy.
Ay, ang alpha amylase, hinalo na ng signal, pero kabulo sila sa questions yun.
Yan.
Kabulo sila.
Nag-buffer
Of
lang
course.
ito nga, Sai.
Yes, of course.
Natambo na ng
partner. I see, so, eager kay mga students mag-answer kay, murag nakaabang ilahang Gcash silang kilad naka-standby.
Partner, oy, Gcash na dampad. So,
Kung sa sini pa ni partner, nagkagulo na ang lahat.
uy,
House
grabe
unlock,
na
magod ang kuan partner. Oy, house unlock, tapos niya, Gcash dayon ang kuan, secret
grabe naman.
amount.
Ayaw pag na partner, kaya mag-expect sila sa premyo.
Sige partner, isa ka sa mga bugas pero luto daan.
Oy, tagaan mo na kung isa ka kilong spaghetti pero nalutog na pundaan.
Okay, congratulations again to all the winners. We will be contacting you for your prizes through Messenger. So abang-abang lang guys.
Yes.
So at this juncture, let us call in our PANAP President, Ms. Roan Angela Rillion, for the closing remarks. A virtual applause, please.
Audible ko, guys? Hello?
Yes,
Loud and
Jen?
clear, press.
Yes. Hello, maayong hapon sa tanan. Maayong hapon gid kaninyo, no? Kanang wow, naagi pa singit nga pabmat ngayong ani. Una sa tanan, I would like to give thanks to the hosts, to the ever wonderful and very fun and dynamic hosts, Angela ug si Kring. Daghang salamat sa inyo for making this event very much lively because as we all know, nutritional somehow a very complicated na topic for the other. So hatag na ko sa ako ang closing remarks. Mayong hapon di ay once again mga kanutrisyon. Karon kay naka-prepare na jud speech. First off, I'd like to give my insight with regards to today's topic, which is the basics of nutritional genomics. Shout out to Sir Wilmar for the very informative lecture. I love how he turns complicated ideas into comprehensible thoughts. According to Sir Wilmar, nutrigenomics is our hope for the future in managing proper nutrition. Isn't it amazing how each and every one of us have our own personalized nutritional needs? Nutrigenomics and nutrigenetics are proof that there is no such thing as a right diet for all or kanang walay one diet for all because each and every one of us are unique. Ano ba? Genes are more than just life's foundations or building blocks, ika nga nila. It can also dictate our own nutritional needs, and it can also help us discover our body reacts to certain foods. Actually, with the help of this topic, actually ako, I am a lactose intolerant na I am lactose intolerant. So with Sir Wilmar's lecture, I've learned na OMG na it has something to do with nutrigenomics or nutrigenetics. This is why nutritional genomics is the path to personalized nutrition. And also, I would like to give my thanks and congratulate the nutritional S&D for a very very successful first session. Kudos sa inyong team. I would also like to mention the people behind behind sa technicals, sina Kez for the publicity materials, si Vince ba daw to for handling the technical gid mismo sa music and everything else. I would also like to mention Rhea, sina Kring, sina Ange, and the rest. Wala na ko na-mention, sorry kay wala dyan ko ka-memorize, pero for a very, very successful, very, very good guys, emphasis on very, very, because this has been a very wonderful session, good. Sa tanan naminaw, ug nagtuon kauban namo karon diri sa webinar, most especially to the batch beta-glucans for extending an arm in setting everything up from the clinic up until this webinar sa clinic sa head sa among sa setting up sa clinic. Kudos pod sa amo ang team leader na si Patrick ang vice chairperson sa atong organization. Thank you, Pat, for leading us, Pat, for helping everything. For helping us with everything yun. And daghang salamat sa inyo, ha? And also, I would like to acknowledge the presence of our department chairperson. Nakita na ko to si Doc Alin Dere, Doc Alin Marapaw, our former Pan Alpha Phi chapter chairperson, Ms. Karen June D. Simon. Hi, Ate Car, and the rest of our seniors nga naadiri, the batch Alpha Amylases, who spent their time with us here. Kabalo ko nga busy na gyud mo kay, di ba? Clinical naman ninyo karon. So, God bless sa inyong OJT, and daghang salamat sa inyong pagkahin og oras dire sa webinar. Mao lang to, no? And I hope each and every one of us here are doing fine. I hope you are all doing great. Maayong hapon sa makausap pa, and may God bless us all. Bye-bye.
Thank you
Thank
very
you,
much,
Jel.
Jel. So, ayun, no?
Kudos to us. Kudos to us,
Yes.
everyone.
Pero partner, murag nag-flood sa comments, partner.
Hala, oy, nahalagi na,
Ano,
napansin. Murag na kahiun di partner sa kakilig. Kaya naka-special mention. Murag complete na gidayahang kuan partner. Complete na iyahang panihapon. Murag okay na matulog sa dito. Damgo na sila magkita.
Pag-ingat mo sa iyang ngalan ganina partner na siya. Pero na nakuhaan ng Zoom. Oy!
Partner, namin ito yung mga favoritism din ng hitabo.
Yes, partner. Murag ra to mga ganap.
Grabe, nakagay partner, no?
So, that's a wrap, everyone. Thank you for attending today's webinar. And we are flashing the code for your attendance na, so please take note of it.
Thank you, everyone. Thank you sa pag-attend. And also a reminder that we will have our second day webinar tomorrow, same time at 1 p.m. to 5 p.m. in the afternoon.
So
Another reminder,
okay.
after filling out the attendance form, a link will be posted in the PanUp Facebook page, and we will be sending it also in the chat box for the evaluation form. Please, guys, fill out the evaluation form and also the attendance link. Thank you.
So this has been Christine K.S. Erdanza.
And this is Maria Angela Oclarit, your MCs for this afternoon. Thank you and have a good day.
Bye-bye, everybody.
Bye,
So,
guys.
see you tomorrow.
Bye everyone. Thank you.
Kita kits tomorrow.
Thank you, Sir Wilmar.
Well,
Thank
thank
you,
you so
sir.
much. And
Thank you,
to the
sir.
rest of the PAN AP officers. Attend mo ugma ha kay external ato ang visitor.
Yes. Thank you. Thank you, guys.
Vince,
You can
I
now-
am overwhelmed.
Wow, grabe.
Play
You
na
can,
tong
now
Wala,
background
guys.
music.
you can now leave the Zoom. Bilin lang si Jel.
Oy,
Joke
kahadlok
lang.
ninyo, oy. Ala, oy. Sige na, mag-leave na sad ko kay napokoy ato ang haya. Bye-bye, guys. Thank you and
Bye-bye.
congratulations.
Congrats, Jel. Thank you for the closing remarks.
Hi daw, Jel. Ano ang nagman sa mong tech?
Kinsa daw?
Hi daw, ano ang nagman sa mong tech?
Kinsa mo na siya?
Hi,
Okay lang.
Vince.
Kilig naman na siya. De, joke lang. Dito,
Uy!
oy. Bye-bye, babe.
Thank you, everyone.
Bye-bye. Congrats.
Thank you.
Thank you, Ate Sai.
Grabe nga hangi o Vince. Sa GC pod. Eh, so live man dahil niyo, naka-record. Oh my God.